Hello guys, I'm back, Patrick from the Backyard Science Lab, and today, or recently, I was challenged to give my thoughts on global warming. And today we're going to be tackling one of the things about global warming, about water rising. And the weird thing about water rising is that I have this glass of ice water here that's been sitting out for just a little bit less than a half an hour now. And I've had ice, a lot has melted, and the water level has not changed. So why are the glaciers and poles they are melting, but why are they melting and apparently raising our water? So we have a thing of fresh water here. And to mimic our poles, we're going to have these bigger ice cubes, and then these smaller ones as all the other ice and glaciers. So I'll get this tape to measure, once this water settles down, the top of the water right here. So right now, the top of the water is right about there. So the top of this tape is the top of the water. So now we're going to let this melt, and we're going to see if the water level changes. Okay, so we'll see when this is fully melted. So we can see that all of this ice is melted, and it's not really risen. And if it has, it's by so little that it could have just been me placing this tape on wrong. And this does really show how, even after all of the ice is melting, which is projected to be over 300 years from now, this is all what happens. So while there's one thing that was a little off in this experiment, is that the oceans are made out of salt and salt water. So I'm going to refill this and reset this experiment with salt water. So I'll cut to when this is now salt. Okay, this is good. We measured out the exact content of salt so that this is as close to seawater as possible. Tastes like the sea. So we need to get our ice, and then we'll put our ice in and measure it and let it melt again. Okay, this should just about the line. Does that look good? Does that look good, filming crew?
The left looks good. Looks good.
Okay, so we'll time lapse this for it to melt, and we'll see if there's any change. All of our ice is melted here. There is a little bit, but as we can see, the water level hasn't really changed. And there's so many factors to this that we can't do consistently. The surface tension of the bowl, of the water, of the ice, and all of this means that we can't really get a thorough estimate, even the waves that may hamper this testing in the ocean. And this is sped up 250, 300 years, where estimates show that New York will be underwater, but ours show that this hasn't even rose a centimeter. So why is ice projected, or why does ice do this and not overflow? Well, the thing is that the ice is marbled with water and air. So what's under the water is the same displacement as what is above the water, as the air that is under is the same weight as the water above, so that when they even out, the air goes up and the water goes down, keeping it exactly the same. So this shows that there wasn't really any difference of what we saw. So why does global warming and all of our estimates say that the water is rising and that we should be concerned about this. Well, that's what we're going to talk about in the rest of this series. One thing I did not equate to in this experiment is that all the ice that is on land, which is all the ice on the South Pole, is on land and is not floating. It is above the sea level. So when that melts, it will add a little bit. And all the other ice that's everywhere in the world. But if you'd like to see more of this global warming series or any of my other videos, subscribe and like this video. And in the comments, let me know if you have any questions you want me to research or make a video about.